Hello, welcome. The golden path to SpringOne. I am happy that you're here joining us from wherever you are. We have a few people here. Let us know where you're from. Say hello in the chat, and welcome, Thomas. This is
Thank you
wonderful.
very much. I'm so happy to be here. Yes.
And Thomas Vitale, am I saying it right? Because this is our first time meeting. I'm very excited. I've
Yes.
read your book.
Yeah, me too. It's so great to meet you. It's Thomas Vitale. Yes.
Vitale. Oh, wonderful,
Yep.
wonderful. So I'm excited. I find myself everywhere I go on the internet, all the Slacks and the chats and all this, even the Stack Overflow issues. You're already there. You're beating me to it everywhere that I go, and it feels good. So I feel like we've kind of been doing this journey together, and it's been wonderful. So what are we going to hear about today?
Yeah, today I'm going to talk about paved path to production. So we look at all the way. We start from the development workflow and see how is the experience when working with Kubernetes up to delivering something out there in production so that our end users can get some value out of it.
I
And I'm
think I
so
know
excited to
the
talk
answer.
about this. It's a great topic.
I have a question for you before we start. I think I know the answer.
Yes.
Do you run Kubernetes on your laptop?
In general or right now?
Yeah, both.
Well, I guess the answer still is yes. I use both local Kubernetes cluster and public cloud clusters. Yeah.
Wonderful. For those of us that don't know you, for those of us that haven't seen you out in the public sharing all of your wealth of knowledge, tell us a little bit about yourself.
Yes. So I'm a software engineer and architect at a company called Systematic in Denmark. I'm really passionate about anything cloud native. Really, I've been working with Java and Spring Boot for several years and working with cloud native technologies. Big supporter of open source technologies. That's why I'm always around. Like I like to contribute as much as I can across different projects, both in the Java space and the cloud native space. And recently, I managed to combine all these passions I have into a book, Cloud Native Spring in Action, where I cover both Spring Boot and Kubernetes and how to work with cloud native applications in general. Yeah.
It's a great book. I highly recommend it. I'm going to do a quick shout out to we have folks from London, from Turkey, developer guy, excellent. Hello from Dubai, Bulgaria. As I'm also, I try not to miss anything from Thomas. From
Thank you very
Tunisia,
much.
look at hello Anan, excellent friend of the show. Hello from Cluj. Hello, I was in Cluj just on Friday. Excellent, never missed. This is so wonderful, wonderful. We got people from all over the place.
That's fantastic. Thanks everyone for joining.
Yes, thanks
It's
for
amazing.
joining. Anything else? I'm going to turn it over. Are you ready?
Yes, I'm ready. Yes.
All right. We'll have at it. Let everybody know. Ask your questions in chat. We'll have a Q&A at the end, but go ahead and put them in. And yeah, we'll get to them at the end. I just want to make sure we have everybody's questions. All right. Excellent. Good luck. I'll be taking
Thank you.
notes.
All right. So let's get started with this journey from our development machine up to production on Kubernetes. So you already heard about me. So let's keep that and start with an important question before talking about technologies. Why do we build software? Now, there probably are multiple answers to this question, but perhaps most of the times we build software because we identified a problem out there and we figured out that perhaps we can solve that problem via software. And then we do that, we implement a software solution to solve that problem and ultimately deliver value. We deliver value to our end users, to our customers, and to the business. That's why we build software. We want to deliver value. So the way that we deliver value, the way we go from an idea up to production is really important. We want to really maximize and optimize the way we go there. Once we have an idea, we get developers involved into making it real, into implementing that idea into software. And then we start this path to production that in our case, in this presentation, I'm going to assume is Kubernetes. So how do we design this path and how can we optimize our journey to production? Today, I'm going to focus on 3 goals. The first goal is that I want to achieve a rapid and continuous feedback loop. This is extremely important while we are in a development phase. Then I want to have reduced cognitive load. Even if we add new technologies, I don't want, as an application developer, to be overloaded with too much things I need to think about. And ultimately, I want to obtain a clear and safe path to production so that I can focus more on my application business logic and rely on something robust and something safe that can help me get that idea out there in production. So let's get started by looking at the development workflow. And for that, we need an application. So of course, I'm going to use Spring Boot. So let's bootstrap a new project. I'm going to go to start.spring.io, initialize a new Spring Boot project. I'm going to use Spring Web. I want to build a very simple web application. I'm going to use Spring Boot Actuator. We're talking about production, and Actuator is amazing because it provides a lot of different endpoints for monitoring and managing the application in production, all out of the box. And then I want to improve my developer experience even further, so I add Spring Boot DevTools. In particular, I like the live reload functionality offered by this library. Cool. Now I can generate the project. I have already opened it in my IDE and implemented a couple of endpoints. So let's run the application and verify that it works like that. So I'm gonna send a request to port 8080. That's where my application is listening to. And we get the message back. Let's verify the books endpoint as well. And it's working. All right. So now I can iterate through the idea. Perhaps I want to add a new book to the list. Let's add the Silmarillion, for example. And if I call the application again, I get the updated list. That's because I'm using Spring Boot DevTools. So if we look at the logs from the application, we can see that when I updated this class, Spring Boot detected some changes in the class path and reloaded the application, and that was really fast, 0.19 seconds. And this is our baseline. It's a really great developer experience. So all the iterations we're gonna go through today and all the technologies I'm gonna talk about, this will be our point of reference. So let me stop the application for now and look at how we got there, because we're talking about cloud native applications. And the way we work with cloud native applications is quite different compared to a more traditional approach, because traditionally we would have our runtime, the Java virtual machine. We would have some middleware with an application server or a web server like Tomcat, and then we would package our application as a WAR or ER file on top of it. But when we work with cloud native, when we work with modern Java frameworks like Spring Boot, then we have our runtime and the application is directly deployed on the Java runtime because it's packaged as a self-contained jar. We also call it Uber jar or Fat jar. And if we consider those initial goals I mentioned earlier, and in particular the feedback loop, in the first case, that was quite slow. We optimized it and went from minutes to seconds. So that was quite impressive. And if you look at the cognitive load also, we needed to know much more in our development iteration loop in the previous traditional scenario rather than with the cloud native. So it's a really good place to be. But then we didn't stop there because we started introducing containers. And now with containers, things got a little bit worse. We got a lot of advantage, of course, but if we look at how working with containers compare with the basic cloud native functionality, we notice that we have a different runtime now. We have a container runtime. And then on top of that, we deploy our application packaged as a container image. This is great. It's a standard approach that we can use independently from the specific language or framework, but it comes at a cost because now we have to build this container image. So the feedback loop became a little slower. And also we need to know about containerization. In particular, we need to know how to write a Docker file that is the list of all the instructions we need to build a container image. But there are ways that we can optimize this. Even though we added this additional complexity, we can maximize the benefits and at the same time reduce the cognitive load. And I really like using Cloud Native Buildpacks for that. With Buildpacks, we can convert our application source code into a container image without writing any Docker file or writing any instruction on how to containerize the application. And the good thing about it is that it works across different languages and frameworks. Now I'm using Spring Boot, but it works, for example, with Go, with .NET, with Python, with Ruby. So it's really a polyglot tool that I can use to obtain an image. And there are several tools to work with Buildbox. One of them is the Packs CLI that I can use. It's provided by Buildbox. But since I'm using Spring Boot, I actually have the same functionality provided out of the box as part of the Spring Boot Gradle and Maven plugin. So if we go back to the editor here, I can run from Gradle a task called boot build image. And in Maven, there's a similar one. And this one will build an image. Now about this, so Cloud Native Buildpacks is a great technology. In particular, is a specification, and then there are multiple implementations available. Spring Boot out of the box is using Paketo Buildpacks. And at the moment, there is no official support for ARM64 architectures, but there is some community support. And in particular, I'd like to thank Dashon, our host today, because thanks to his work, I managed to run Cloud Native Buildpacks on my Apple Silicon computer, because Dashon is maintaining a version of Buildpacks with support for ARM64 and even with multi-architecture support. So that's awesome. Thank you very much, Dashon. So we go back to the step here. The first time we run Cloud Native Buildpacks, it takes a few seconds because it needs to download all the dependencies. But after the first time, then it will be much faster. So let's give it one more second. And there it is. We are getting an image. It's called book service. All right. Moving on. Almost done. All right, successfully built. Now I can run it. I'm using Podman, but it works the same way with Dogger or Eddie, and I run my image. So let's verify that it's working correctly. All right, let's send the request. Install port 8080 / and there it is. Welcome to book service. Perfect. So now I'll stop the container. And at this point, this might be enough, but once we start working with containers, then at some point we're gonna need to have a way to manage them at scale. So we're gonna need an orchestrator, and that's where we start introducing Kubernetes. Now, if I want to deploy this with Kubernetes, I need to start writing some configuration specifically for Kubernetes. And for this case of a web application, I need a few configuration files. The first one is a deployment object. In here, I specify that I want to deploy my book service application with one replica. I point to the specific image and that the application is listening on port 8080. I can use this to deploy my application on Kubernetes, but the application will not be available through the network. So I need to create a service object as well. And this will expose the application from within the cluster. But from outside the cluster, that's where our end users are located. So I need yet another object called an ingress to make that available outside the cluster. So we go here, and I can use the Kubernetes CLI, kube control, to apply those configuration file to a local cluster. I have a local kind cluster. Let's do that. The deployments are configured. However, the image that I'm pointing right here is only available on my local machine. Since I'm in the development phase, I didn't push it to a container registry. So I need to upload that image inside the cluster. And with kind, I can do kind load Docker image book service, like that. And need to specify the name of the cluster, TVS cluster. All right. So if we check the deployment, we can see that the application is deployed. We can even give it a go on port 80 this time from outside the cluster. And we can see that it's working. And I'll clean that up because I don't really like to work with this, right? It's a lot of different manual steps. So there must be a better way. Let's have a look. We introduce Kubernetes. So first, we want to compare it to our previous situation. We still have a container runtime. But now, on top of that, we have a new middleware. That's Kubernetes. And on top of that, our containers. So a common mistake here is that we expose Kubernetes directly to application developers. And that means that we get a slow feedback loop, and we get a lot of extra cognitive load that really doesn't belong on the application development side. So we need to do something to improve the situation there. But first of all, I want to make the feedback loop faster. And then we're going to look at some techniques in order to also reduce the cognitive load. For the feedback loop, I'm going to use Tilt. And with Tilt, I can automate my flow. It's also called inner development loop, where I'm going to code something. I build a container image. I upload the container image in the cluster and run it, do some testing and debugging, and then code again. With Tilt, I can automate this whole life cycle. So if I now go to a different namespace, we can give it a go. I can say Tilt up. That's how I operate Tilt. And now what Tilt is going to do is the same exact operations that I've been running so far manually, but automatically. And that is controlled via a file called a Tilt file. Let's have a look at that. You can see that we have a build configuration, and this is running the same command I ran earlier, boot build image. And then I'm letting Tilt defining the image name, so to have a unique reference ID. Then I'm using the same configuration manifest to deploy them. And then finally, I ask Tilt to expose my application to port 8080 and also 9090 for debug. So this will make the whole development loop much faster. I still need to write some configuration. I can automate that. I can use a tool like JCube to generate those manifests automatically. But at least I don't have to continuously containerize my application and then deploy it again. I can follow the sequence of actions within Tilt from the CLI, but there's also a very convenient GUI. So let's have a look. We can see that it's running the Gradle boot build image command. So it will do the same thing that I did earlier manually, and then it will deploy it and finally expose it through port 8080. And every time I make some code changes, it will synchronize those changes to ensure a live update. This is a feature that is offered by Cloud Native Buildpacks, which supports live reload. And then with Tilt is the final piece in order to have this flow all working together. And the final experience will resemble a bit the initial one. All right. So we can see that the application is deployed. We can even test it before moving on. Let's see. Welcome to book service. Perfect. Now, when I'm done working with Tilt, I can say Tilt down, like that. Awesome. So if we go back at our initial goals, what we achieved so far is that we introduced containers and Kubernetes. And thanks to Tilt, we managed still to have a rapid and continuous feedback loop. But yeah, we had to introduce some tools to do that. But then when it comes to cognitive load, we didn't really reduce it, because even if we automated the flow, we're still responsible as application developers of the containerization, configuration, and deployment process. And at least for now, I still don't see a clear and safe path to production, because some of these actions I've been doing as part of development, they will be part of the pipeline. So how are these two parts of the path to production working together? Let's find out. We first need to build a CICD pipeline. So let's do that. It's going to be a simple example. We can trigger the pipeline every time we push some new code changes to Git, check out the source code. Then we build a container image. We configure the workload. So those Kubernetes manifests I showed earlier, we have to configure them. And finally, we deploy the whole thing. And we can implement this using an orchestrator like Tekton pipelines, like GitHub Actions, like Jenkins. And this is a great pattern. I call this an imperative pipeline that works in many different scenarios. So for example, I use this in most of my projects on GitHub. But when we are working with Kubernetes in the context of an organization, especially when we have more and more teams that need to be using Kubernetes and these cloud native technologies, we start identifying some issues or some drawbacks of this approach, basically, because if we think about it, this is a very rigid system. If we want to make some changes to how we build a container image, we can do that. Or if we want to have some other role in the organization, maybe there's a security expert, an application operator, a platform engineer that are very skilled in Kubernetes and can provide a secure and compliant configuration to our workloads, they can't really do that very easily because the pipeline will live together with the application source code. Usually it's the developer being responsible for it. We can have some shared responsibility, but if it's shared, it really means that nobody's responsible for that. And it's really tightly coupled, so it's difficult to make changes only on part of the pipeline. And even if we do, then we every time have to start over. We have to trigger from the very first step and go through the whole pipeline, even if we only updated something in the final step. And then, as I said, there's no clear separation of concerns because it's hard to collaborate or separate concerns on different steps in the pipeline. And overall, it's hard to maintain. So when we talk about delivering value, I mentioned application developers earlier, but then we realized that we actually have different personas that collaborate and work with the path to production. So we need to ensure a way for all these different personas, all these different people to collaborate and have a clear separation of concerns. As I said, we might have application operators, we might have security experts, we might have platform engineers. So we need a different approach. We need a different pattern to build our CI/CD pipeline. So let's think about this, because if we look at how we build applications, if we get into a situation where our system is quite rigid, it doesn't scale, we want to change part of it in an independent way, following a different life cycle, we actually know what to do there, right? We can break the monolith down. So what if we extract the deploy workload activity out of the pipeline and make it independent? Then we can trigger it based on events. So we can have the configure workload step that outputs Kubernetes manifest. And then the deploy workload activity can watch the repository where these manifests are pushed, and every time there are changes, it applies them to the cluster. Hey, look at that. That's GitOps. That's how it works, right? So we can start doing this approach and apply it for different operations that we want to make them as independent, loosely coupled services or activities within the pipeline. We can do that for the configure workload. And in this case, the output from the previous step is a container image, and that is what configure workload will watch for changes. And we can even split the checkout source code operation. This is what I call a reactive pipeline. And with this approach, we get loosely coupled activities. We get a clear separation of concerns, because now I can have an application operator updating the way we containerize the image without affecting the rest. Now, a concrete example. A few months ago, we got an OpenSSL vulnerability, a library that is used in a lot of base images. So what happens if we need to fix it very quickly? An application operator could rely on Cloud Native Buildpacks, because one of the features of Buildpacks is the possibility of rebasing an image. So it will update this service, this activity, with the patched version of the base image. And using Buildpacks, it can rebase all the images that have been built using this action. And we can apply this at scale, so we don't have a one-to-one mapping between application and pipeline, but we can reuse all this system across multiple teams and multiple applications, which is an extremely powerful concept. So it's very flexible. It's based on events. It's an event-driven system now. So we can add new steps. We can remove them. We can switch implementation. And we can build a consistent path to production. So we have identified the main pattern, but we still need to figure out how to implement it. In particular, what is the API at the entry point of this pipeline? How can we trigger this whole flow? And also, since we talk about event-driven systems, we need something in order to intercept the outputs of some of these activities that also pass them as inputs to other activities. So we need some kind of message broker. And a solution to that is Cartographer. Cartographer is defined as a Kubernetes native choreographer. Once again, we are applying the same concepts from software development for event-driven system, where we have the choreography pattern that we can use in order to make sure that we pass these messages around. We have each of these activities that have well-defined inputs and outputs, and then we have a choreographer that takes care of moving this data around. And the way I like to define Cartographer is as a framework to build paved path to production. So let's start by talking, by looking at Cartographer from the developer point of view, because that's where we started, right? The API that we have as developers is the Workload API. And it's very developer friendly because we don't need to know any low-level details about Kubernetes, but we use this API to provide information that only us as developers know. That is the name of the application, band service, for example, the type of application, web, the Git repository where my application is located, and the branch, main. That's it. I can provide this API to the platform that uses Cartographer to offer these services. And then I don't need to worry or be responsible for how the application is containerized, how it's configured, or how it's deployed. So let's have a look at an example. So let me move to a development cluster now. What I can do is, once again, say tilt up. Now it might seem I'm doing the same thing as before, but now the result is actually quite different because what I'm actually applying with tilt is the workload configuration file. So you can see my application here. I don't have the Kubernetes manifest anymore. I just have the workload API. And here I'm specifying the name and the type, where it's located. Since this specific application is in a subdirectory, I'm also passing the subpath here. And then I'm using Java 17. So I'm specifying some additional parameter for the system. That's all I need to do. And under the hood, I have Cartographer that initiates that reactive CICD pipeline and go through all those activities to make sure that my application gets built into a container image, gets properly configured, and gets deployed. And me as developer, I'm not involved in that. I can get this service from the platform. Now, if we look at the tilt file, we can see that it's quite different from before, because instead of specifying how to build the application, we just specify how to deploy the workload file. And because I'm working locally, again, my application is not pushed to Git, I need some additional parameters in order to make that work from my local source code. And then once again, I get the live reload functionality, I get the application exposed through port 8080, all the same features from before. But now I'm not responsible for any of those activities. I just provide the workload file. So let's have a look at tilt once again. This will look a bit different from the inside, but from the outside, I just get the localhost endpoint where I can use my application. So my developer experience is the same as before, but I'm not responsible for how it's containerized or deployed. And that's really great. Next, this is the development workflow. Once we're done with all of this, by the way, once I can still do tilt down when I'm done, but I can push my code changes. And what happens is that we start a different pipeline in order to go to production. So we have these three stages. We have the stage where we do the development work. We have the stage where we test and build the application. And finally, we have the stage where we deploy it in production. So before showing an example of that, though, let's have a look at the operator or platform engineer perspective. So how is this implemented? We said that we have all these activities are now part of an event-driven system. We have an API to activate the whole functionality. And now we need to instruct Cartographer to pass inputs to each of these activities and intercept the output so that they can be passed around to interested parties. So it's just like a message broker. And we are basically building an event-driven system. the good thing about this is that all these steps, all these services don't know anything about Cartographer and don't need to know anything about Cartographer, because Cartographer works from the outside. So it wraps all these activities, and it's only concerning about the contract of these activities in terms of inputs and outputs. That means that we are free to implement all of these activities with any tool we want, as long as we maintain the same contract. So I can use Flux CD to watch the source code. I can use Tekton to build a testing pipeline. I can use Cloud Native Buildpacks, in particular KPack, which is the Kubernetes native implementation of Buildbox that not only builds my application, but also sign it using cosign. So we also cover the supply chain security topic a bit. We can use Carvel for configuration and Knative for doing the deployment. And then we have this separation of concerns in place, so we can have platform engineers changing the way that workloads are configured. For example, in terms of, I don't know, some security policies, or an application operator can operate the build stage of this pipeline. So we had some months ago this problem with log4j vulnerabilities in the Java ecosystem. And at the beginning, there was this initial workaround that we could set on the container image in order to at least mitigate some of the risk of that very bad vulnerability. If we are using a system like this, and you can even see that this is a real use case, you can watch on YouTube some real cases of how this was done. You can use Cloud Native Buildpacks to rebase hundreds of different containers, all by basically changing this one operation. Because as I said, this is a reusable pipeline. It's used across multiple applications. So you can really centralize compliance and security in your organization. And then if you don't like any of this tool, you're free to change it. The contract will not change. You can change the implementation freely. So I can use Jenkins, I can use Customize instead of Carvel, I can use Argo instead of Flux, or maybe Canico instead of Cloud Native Buildpacks. And really, sky's the limit, right? Just have a look at the Cloud Native landscape and use all the tools that you like to use. As long as you keep the contract in terms of input and output, Cartographer can work with that. So you have huge integration possibilities. And the way that we tell Cartographer how to pass this data, how to configure inputs and outputs, is via supply chain. Supply chain is the concept in Cartographer that describes the path to production. So in this example, we have a supply chain that works with all workloads of type web. So that's why we specified in the workload manifest what type of application it was. We can have multiple ones. And here we have three activities that Cartographer calls resources. We get the first one that provides the source code into the cluster. Then we use that output as input to the next step in the image build phase. That will output a container image reference, and that will be used as input in the deployment phase. So this is how we look at inputs and outputs and how we configure Cartographer to basically act as a message broker in this supply chain. Overall, we have a situation where we have multiple product teams with different developers working on different applications using different languages and frameworks. It doesn't matter. Then they use this very user-friendly interface, the workload. And that's it, because the rest is done by supply chain that can be reused, that can support multiple different languages and frameworks, and ultimately deploy applications in production. That was our end goal, right? Deliver value. And that supply chain, as developers, we don't have to be worried or be responsible for all the tools that are used to implement it, because we have different personas there that can provide their skills and expertise, as I said, operators, security experts, platform engineers. So if we look now at the same example, we are done with the feedback loop here in the development phase. So I'm going to push my changes to Git, and that starts the next phase of the path to production. So if we go now on the build cluster, I can see I'm using the Cartographer CLI, and let's have a look at book service. What we have here is a supply chain that was used to support this specific source, so the book service application on my GitHub repository, and it went through a series of activities. You can see that I use Flux to get the source code. I use Tekton to run tests. I used Tekton again to scan my source code using Trivy, the vulnerability scanner. I use Kpack to build the image. I scan it once again with Trivy and Tekton. I apply some conventions and configurations. And finally, I published a pull request. Now, this is not always needed. It depends. If you're doing continuous deployment, you would just push the changes. Otherwise, we get a pull request. We can see here, we got the pull request from Cartographer. I can inspect the changes. So it builds a new image for my book service application. So let's approve it. And then if I check my production environment, I can see that my application is running using Knative. So I can have a look at this one. You can see it's even running. We can do it in the browser. So you can see that it's running over HTTPS because with Knative integrated with Contour and Cert Manager, I get the application exposed via an ingress endpoint, and I get a certificate generated automatically using Let's Encrypt. So this is a certificate which is trusted by the browser. You can see connection secure, which is quite convenient. And that was the whole supply chain. So we had these three steps, these three environments. We have the development environment where we do this continuous iteration loop. Then we push our changes to Git. We enter the build phase that ends in producing this configuration manifest and pushing them to a dedicated Git repository. And finally, we have different environments for staging for production where we deploy the application and users can actually take advantage of it. That's where we deliver the value. All right. Now, one last thing I want to talk about is how do we implement these different activities? We talked about the Workload API, how to build the supply chain, but now let's have a look inside at one of these boxes. For example, the watch source code box and using Flux CD. So Flux CD offers an object called Git repository that we can use to pass information on which Git repository to monitor. This information is the input to Flux CD, and we can have Cartographer provide that automatically. Since we are providing this information via the Workload API, we can ask Cartographer to pass it on to Flux CD. So we have the name from the workload and the Git information from the workload as well. That's the input to this step. Next, we need to define the output. This is the output of this operation is source code. So in Cartographer, we expect to get information on the URL and the revision of the source code within the cluster. We have different templates, they're called templates in Cartographer, based on the different types of outputs that each of these resources might have. Since we are working with source code, the output will be URL and revision of the source code. When we are working with images, then the output will be a reference to the image. So that really depends. But if you look at this, the definition of this source template is done based on the output. So I can go ahead and replace Flux CD with something else, but the contract, the external contract will stay the same, so it will not affect my supply chain. So I'm really free to swap tools or to make any changes internally in a very isolated way. And that's why we broke down the monolith to begin with and started implementing pipelines in this reactive event-driven way. And that is the template API, which we use to define each of these steps. One last topic I want to cover is about capabilities over responsibilities. Now, I started at the beginning of this presentation comparing different types of application development setups, like the traditional one, Cloud Native, containers, and Kubernetes. And with Kubernetes, we got all that amount of cognitive load for developers. And I said that there really needs to be another way. It all depends on the strategy we adopt to implement and start using Kubernetes within our within our organization, within our team. And the point is, we don't want to offer Kubernetes to developers and that's it. Then developers have to learn and configure and be responsible for all these tools. We really like these tools, but perhaps we just want to keep Tilt or a similar tool that gives us the opportunity to start this continuous development loop. But then we want probably the platform to take care of configuring and providing all these tools for us. So when we talk about shifting left, sometimes we are too literal with that. We don't want to shift left all these tools with the responsibilities on the developers for those tools. We want to shift left the capabilities provided by the platform. But then we want to have someone like a platform team that is highly skilled and specialized in building platforms, in working with Kubernetes, in working with these cloud native technologies. And that's the way we want to work. Clear separation of concern. Platform uses this service. We'll configure them together. And we saw that we can use Cartographer then as a developer to interact with all these services offered by the platform as part of a supply chain. So that was the end goal. Though we have one last thing, that since we kept Tilt in our developer toolbox, we probably need to figure out how to deal with this workload specification and Tilt configuration. Because right now, it seems like a lot of boilerplate there. Because the workload will always have the same structure with this information, of course, different for each application. And the Tilt file probably will always be the same. So we might have a way to have this auto-generated for us from the platform. And now a popular way of doing that is using Backstage to build a developer portal. Now, Backstage is a CNCF project. It's been originally developed by Spotify. So let's have a look at it. It looks something like this. So as a developer, you can look up all your application in here, see the APIs exposed by other teams, check documentation. You can do a lot of different things. This is a framework to build portals. So then it's up to you, or it's up to the platform team to implement all the services that a developer might need on top of Backstage. And in particular, Backstage has the concept of golden path, which is a concept popularized by Spotify. So using a golden path, I can get a lot of things auto-configured and bootstrapped for me. So let's say I want to build a new Spring Boot application, perhaps a reactive application. I can go in here and provide some information. Let's call it demo Backstage. Provide information on the Java package name. Let's say I'm working with Team C, so that will be the owner of this application. And then I want to auto-generate my GitHub repository as well, like that. Let's review the information, all right, and create this Git repository. So in a few seconds, I will get the Git repository link like this. Let's have a look. So we can see that we get a Spring Boot application. We can check the information on the dependencies. We get Spring Boot Web Flux. We get Actuator and DevTools, similar setup I was using earlier. But then we also get the configuration workload file, already pre-filled with all the information that I need, like my GitHub repository, the branch, the Java version used, the name of the application, the type of application, and I get the Tilt file as well. So now I can go ahead and check out the source code. I can go in go into the source code and run Tilt up. And that's it. So I can now focus on building the business logic of my application, on implementing all those initial ideas that we started with because we wanted to solve a problem. So I don't need to spend too much time configuring the setup. I can use a very nice interface to generate the project for me. I use Tilt to enable this continuous development loop. And then we can see that it's going through the usual supply chain that we use now everywhere, both in development and for the CICD pipeline. And yeah, nice developer experience there. So if we look back at the initial goals, we got still a rapid and continuous feedback loop. We managed to reduce the cognitive load. We just saw that we only need to know about this workload API, and then containerization, configuration, deployment, that is provided by the platform. And we also got a clear and safe path to production, because the concept of a supply chain provided by Cartographer lets us use that everywhere across the whole path to production, which is not just the CI/CD pipeline, but we also need to consider the development workflow. Now, if you like all these technologies and processes, this is all open source, so I'm going to share the code with you. But I'd like to mention that all the source code you find, of course, is not production ready. But if you like this approach, if you like these patterns, all of these things are the foundation of an enterprise product called VMware Tanzu Application Platform, which provides, on top of all these technologies and patterns, a great developer experience focused on supply chain security and really on accelerate the path to production. So you might want to check that out. I have some resources for you with all this source code, also an article from Dashan about how to support Cloud Native Buildpacks for ARM64. And then one thing I'd like to mention is that I've been using a Cartographer CLI that is a proof of concept. Let's see where it is. Right here, that I've been working on recently. So feel free to check that out, because right now Cartographer doesn't have its own CLI, but there are different functionalities provided by different CLI. For example, some of it comes from the Tanzu CLI. So I've been trying to gather all these different functionality into one single CLI that perhaps eventually will be officially part of the Cartographer project. But for now, it's a proof of concept. So just a heads up if you decide to give it a go. Yes. With that, I am done. Thank you very much for joining this session, for listening. I hope you got something out of it. And now we have some time for questions. So if you have any, please leave a comment in the chat. Oh, Dashan, I think you're muted.
I was too excited. I didn't want you to hear me getting all excited when I was backstage. A lot of great stuff. And we really have one question. It's kind of an important question. So I'm going to pull it up here. New great tools. However, as a dev team, why should we use it and learn it if we can, for example, use Compose with Docker or Scaffold with Kubernetes?
Yeah, that's a very fair question. So as I said at the beginning, for example, when talking about the CI/CD pipeline, the initial pattern, that works great in a lot of different situations. So it really comes to, does it make sense, or do you have the problems that these technologies have presented or these patterns solve? Same thing for Kubernetes, right? You don't have to use Kubernetes if you don't have the problems that Kubernetes use. Now, you mentioned two things. Of course, if Docker Compose works fine for you, you have a small system, you can use that both in development and in production. That's perfectly fine. If you don't have additional needs in terms of scalability, for example, or high availability. And regarding Scaffold, actually, Scaffold does, you can swap tilt in my example with Scaffold, and it works in the same way. And I actually have a repository there that also shows the same thing with Scaffold. So you can have a look there afterwards. I have this GitHub repo about developer experience with Java and Kubernetes. And I showcase different tools. So you can see Scaffold and Tilt are both there. They both accomplish the same. The configuration is a bit different. Tilt use Python and Scaffold use YAML. Also, Tilt has some GUI. But yeah, I think whatever works to you, that's the best tool to use, right? Because you know your requirements and your use case. And of course, we have so many options that, sometimes it's hard to choose.
One of the things that was mentioned in there, the first part is, what about for a team? One of the things that I'm a big fan of, one of the things I've been trying to share with the community is running Knative serving locally on my laptop. One thing that helps in that team environment, if I've got a bunch of microservices running in Docker Compose, they're all up and running, they're all consuming my resources, right? So depending on your size, depending on your capabilities, your resources, with Knative serving, I can actually be working with those exact same microservices. If I'm using the Cloud Native Buildpacks, I'm compiling for native images, I can have these really fast responding services scaled to 0, so I can still use my IntelliJ and Slack at the same time, right? And I can have the entire suite of applications running in the background. So that's one thing that I'm a big fan of. And yeah, you were just bringing me joy the whole time. It feels good to have somebody else that's kind of seeing the value of these patterns and these tools the same way that I do. I get excited about it. And I'll be honest, that path to production, I actually have one team that I'm working with that's running Kubernetes locally for that Knative serving experience, but they're running Docker in production. They're running Docker Compose in production, and that's okay, right?
Yeah.
There's different needs. Still the same container that was on the laptop that's running in integration dev and prod, but different use cases, right? So yeah, there's
I love Knative.
Yeah.
It's so intuitive and really developer friendly. And if you're working with serverless application, I would suggest having a look at Knative Functions, which provides this CLI that you can use both to auto-generate a project, do the build with Buildbox actually, and then deploy it with Knative Serving. So you get everything in one tool, in one CLI, and yeah, it's an amazing developer experience.
Can I ask you one more question?
Yes, of course.
One of the things that I didn't see on there is, where do you get your metrics? We talked about actuator at the beginning. I want to have my metrics. What do you use? What do your metrics look like?
Yes. So let me share my screen again.
Okay.
Yeah, let's see. I think I still have. Yeah, so yeah, I just realized I wasn't sharing. So this is the repository I mentioned earlier about developer experience with Java. So you can find different tools, including Scaffold, Knative, there's Telepresence, another great tool. So we have different tools that really help us as developers. So what I wanted to do is, yes, check this. I'm using Knative Serving. As you can see, I get this URL. And just let me be sure that I'm in the right cluster. Yes, I am. So I have my actuator. Oh yeah, of course it's protected. So this is available to the public internet, right? And because I'm using a supply chain, I get all the right security and configuration in place. So a mistake, like there's no possibility for me to make a mistake and expose actuator with a lot of sensitive information for you to see. This is available to the public internet right now. So I actually cannot show you, but of course I can go into the cluster and have a look at that. But this is part of the supply chain. So actually, great thing.
Excellent.
Yeah.
Any other questions? Yeah. What I'd like to say at home is, if you come over to my house for dinner and you leave hungry, that's your fault. Right now, it's dinner time. If you've got questions and you leave without asking your questions, that's on you. This has been an amazing talk. I love your book. I use it almost like a reference. I'll be honest. I use it like a reference. Wow. I'm always.
It's really great to hear. Thank you.
It's been just a wonderful part of my collection, and yeah, we're doing amazing things. This has been a super great session. So I'll give folks a couple minutes. I know that there's some delays. Folks that are joining us from other parts of the world are a little bit behind, so I'll give them a little bit of time to ask questions. What else is on your mind? What are you looking forward to the next days, weeks ahead? What's on your mind?
Yeah, I would say more Kubernetes, more Spring Boot. Yes, things are really great right now. We got Spring Boot 3, we got native images support with GraalVM. And thanks to you, I can use it on my Apple Silicon computer. So that's fantastic, right? And that's especially useful if you're working with Knative, because we can scale to 0. And then when we have to scale up, we need the application to start fast. And using Spring Boot with GraalVM native support, we can do that. And
yes, we're getting good feedback. Sounds like things went well. I was excited. I was happy. And yeah, it's a great pattern. I put up your GitHub. I highly recommend that everybody goes to your GitHub and clicks on the follow button, because you're always doing amazing stuff. It's one of those patterns I like to pick up. I like to keep an eye on what the cool kids are doing. I like to follow their GitHub repositories.
Yeah, also I'll share the slides on my social network. So if you follow me on Twitter, LinkedIn, or Mastodon, I'll share the slides. I'll share all these resources and links to source code and stuff. So if you're interested in getting those, yeah.
Wonderful. And the video is going to be on YouTube after, so don't worry, you didn't miss anything. The videos will be live, and that's wonderful. It doesn't look like we have a whole lot of questions. I think you knocked it out of the park. You did an amazing job. I can't wait to have lunch with you soon. And yeah, I think we're
Me too.
good. I think we're good. Excellent. Wait, oh, last one. Have you installed Java 20 yet?
No. I was about to, but I had my old demo set up, so I figured out, okay, let's not touch it, because I always install things right before going live with the presentation, and
What could
yeah,
possibly go wrong?
I like a challenge.
I like to say a lot of times when the demo goes wrong, that's when we, as an audience, that's kind of when we learn more. That's kind of where we learn, like, hey, what should I panic? Nah, you get to see the pros, kind of think through the problem, and I actually don't mind it when the demo doesn't go perfectly. I find I get a lot more value sometimes that way. So this is great. I did install. I have SDK Man. I did install the latest version. Somebody's asking, will we do an overview of Java 20? That's the kind of thing that you should come to Spring Office Hours and catch up on. That's where we like to do our show and tell. So check out springofficehours.io. And we have Kratzi. We had more people coming from all over the world. We had people from India and from Kenya. So yes, we are. I think we're doing a great job.
It's been amazing. Thank you all for joining. So it's so great that you took the time to join us here today.
Well, all right. I think we're good. I think we should call it a show. Thank you so much for joining us. Again, check out Thomas's book. Check out his GitHub repository. Thanks for joining. We'll have more next week. Thank you. Before we go, I'll talk about Spring Academy. They're adding new stuff every day, every week. It's an awesome new resource that's on demand, easy to follow. And yeah, there's a free path and there's a paid path that gives you this approach for getting your certification. And we can talk about the certifications and the value that's provided there. Thank you so much for joining. We hope to see you at VMware Explorer.